Hey everybody, this is Larry. This is me going with Q2 of the weekly contest 359. Determine the minimum sum of a K avoiding array. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem. So one thing I would preface with this contest and this problem is that I was trying to be more careful with this contest. That's my goal for this contest was that the last couple of contests, I have the algo part okay, but I was submitting it too early and have a silly typos and mistakes along the way. So this contest, I was slowing it down to make sure that, as best as I could, be more mindful about silly mistakes. And for this one, I end up taking about 2.5 minutes. To be honest, I should have, and if you watch the video, I probably could have gone this much quicker. During the live portions, you could look at it ahead because the answer is greedy. But that's the thing with greedy is that one is that you have to prove it, and then the other thing, to be honest, is that I got punked by the constraints because I always say, look at the constraints, I'll give you a little bit hint of what it is. But because the constraints are n and k is less than 50, I was like, there were a couple of conflicting dots in my head, right? Which is, well, it is a Q2. So it should be straightforward, but n and k is 50. Is there like an n squared, n cube algorithm that I didn't know about? So that's kind of the dot that I was going through, and that's what took me so long. And I think what ended up happening was that I was actually I did not have a strict mathematical proof per se, win now or whatever. But in my head, like I said, I spent 2.5 minutes on this problem. I spent probably at least 1.5 minutes with the mathematical proof. So that was a big portion of this part. And the idea here is just greedy. So this is the solution. You basically add the smallest number in which it would not create a sum of k, and that's basically the idea. And here we're going to go through the proof. So the first thing I want to point out is that there will always be an answer, right? Why? Because if k is equal to 50, and this may not be the best answer, but this is an answer, is that you can start with 51, 52, 53, 54, ... right? So that could be your answer. It's not the minimal answer, but it is this answer, and then you could sum it up. So there's always an answer. And then, of course, the other thing is that you can choose number less than 50, right? So this is not a construction thing. So what happens is that, and this is a pair, that means that given a number k, let's say 50, you have 1 plus some k minus 1, you have 2 plus k minus 2, you have 3 plus k minus 3, ... right? All the way. Maybe you have a duplicate, like if k is even, you have 25 and 25, so that actually is good. So you have to be careful, but you can't have both So in these cases, you cannot have both of these numbers for obvious reasons because they sum to k, because that's the definition. So you can only choose so you can only choose one of them, and of course you can choose the smallest one to calculate the minimum sum. So that's basically the proof for this algorithm in a way, or this is another way of saying how to get the minimal answer. And you could code it like that exactly, but greedy turned out to work for that reason. Is that you go 1, 2, 3, and then as soon as you kind of duplicate, then it's no longer good until you get up to k plus 1 again, right? Because there's no pair, at least odd pair, I suppose. But yeah, they tell you about positive, yeah. So yeah, that's basically the idea. The way that this algorithm goes is going to be O of n, but of course, this does not mean it's linear because n is not the input. This small lowercase n is not the input size; it is the input. Input is not the input size. Remember, because the input size is log lowercase n, because that's the number of bits representing the input size, right? So this problem is going to be exponential. In that case, it's going to be O of n, O of big N, O of small n, but not linear. Yeah, lowercase n, but not linear. Same with space, because we use a set, and by definition, that's going to be O of lowercase n, which is exponential, the number of bits that are in the input size, right? Yeah, that's all I have for this one. But of course, the input size in this case is at most 32 for 32 bits. You can also maybe even say, because technically it's 50, you could say it's less than, what's 50, like 8? So the input size is like 8, so it's 2 to the 8 if you want to say that kind of exponential or whatever, or 2 to the 8 times 2 or something like this if you want to go be more precise in terms of, because of, or n plus k, which is, k is also 2 to the 8, and if you add them together it's 2 to the 9, that's why. But still, basically this is exponential. But yeah, I just want to go over the complexity real quick, because that seems to be people are very imprecise about this. But yeah, anyway, that's all I have for this one. Let me know what you think, and you could watch me solve it live during the contest, including all the confusion, and then just submit after I kind of proved it in my head. You could see all of that next, but it's mostly in my head, to be honest. So let me know how you think. Go. True, false, true. Maybe should have read the poem. Any pair of It's just greedy. 2 I mean, it shouldn't be greedy if n and k is so small. Wow, this is a weird problem, isn't it? 4-pointer. Feels like it could be very messy. How is it not just greedy? I don't get it. But I don't have a counterexample. Yeah, okay. Let's just, what's n again? Of length n, okay. If k minus cos is an s, how is this not the right answer though? Okay, I mean, I spent so long because I just wasn't confident. I knew that was how, well, that's what I thought. I think the slow constraints, they try to fool you, and it worked. So thanks for watching. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem, this contest, and everything in between. Let me know how you did. Stay good, stay healthy, take good mental health. I'll see y'all later and take care. Bye bye.